Okay, so today's presentation is really a lot different than the ones I've done before. It's more, I'm going to try to be completely non-technical as much as I can. There's a few screenshots of XML files in there, but I promise you they're not important. The whole point is that I feel like, to a certain point, most people here have not really met the old team that was responsible for either getting to the conclusion of developing the Mannequin system, or implementing it, or working with it. Most people have just used the tools. So let's take a step back and think about it. Anim graphs, or state machines in general, along with Lua scripting, are not bad. They're really brilliant tools. It's just that they are tackling a different problem. So they're super easy to understand. They're low barrier to entry. You can teach anyone to do Lua scripting. You can teach anyone to do a state machine, a graph state machine. They're very good, but they're really, really not built for the complexity of a character. They're just a wrong tool for the job. They are very badly scalable. You end up with these massive graphs and you have no idea what's going on and you have no idea how to do it. Not to mention that, but in all of these, one of the things that really bothered me is in all of these graphs, if you inspect it, it will tell you which animation asset it's playing. So at the very, very best case scenario, if you get all of these and they work brilliantly, and you move them from grunt to witch, to take hunt as an example, and it just happens to be that the guys who are authoring these animations call this grunt underscore walk and witch underscore walk, which is completely fine if you want to have manageable perforce directories. It's not going to work. The animation assets don't match. And so this is the problem. There's not enough separation between what an animation is and what an animation state is. So okay, let's now take a step back and rethink what we wanted. This massive jam of stuff that we need to do for the animations. Start with a very basic idea again. We want to play animations at the very basic level, just to give you an animation and a number of animations, and you layer them on top and you calculate the skeleton. That's a given. We need to do that. We also need to make sure that there's a distinction between what the game considers a game state and the animation considers an animation state. Not everything that is in a game has to be represented by an animation. For example, imagine if you have a crouch and stand. That is a pretty cool case where you want a different animation state based on whether you're crouching or not. But what if you want to just have bleed effect? And that bleed effect is just your glowing red. You don't want an animation state. So you don't want to have a tie between game state and animation state. Next up is what we talked about. You don't want to tie your animation states to animation assets. I want to have my animation states be something unique. Like every single character can crouch, every single character can jump. What that asset means, what that asset plays, what it applies on can be wildly different. If you think about the difference between something like the Hunt Spider, Robinson's Higgs, or a player character, they are all walking or they are all jumping, but they look very different, not just in animation style, but they can look very different in whether this is a full body thing, is this a character that just molds into a different state. So they can look very different even though they have the same animation asset. The same animation state. So we need this separation. Also, we want to do some specializations. A very quick example is every game with zombies, and right now we're doing Hunt, is that you don't want a field of grunts that look exactly the same. No matter how much you do the character customization, if every single grunt walks exactly the same way, players are going to notice it. Brains are wired to notice patterns. That's just how we are. You're going to say, okay, they're all playing the walk into loop again. And it's even worse sometimes when you get them completely in sync or just a couple of milliseconds apart and they look like they're doing the Tonga dance when they're walking towards you. So we want to do some specializations, randomizations without having to do all of this again. I want the animator to be able to give me, okay, you have 40 grunts, here's 40 different walks. And the gameplay guy doesn't need to worry, the animation state guy doesn't need to worry, the AI guy doesn't need to worry. And lastly, it is unavoidable. We will need procedural stuff. We need stuff that is beyond the realm of what the animators can author, simply because we are a game and we are not a movie. We need some procedural stuff. So, switching into sort of project manager mode, awesome, let's do the thing that project managers love the most. Let's assign tasks, division of labor. So fine, this big thing, okay, at the lowest level we need something that does the groundwork of playing animations and computation. Sure. We need a system that would take the description of the game state and translate that into animation states. We need a system to map said animation states to actual animation assets. we need a way to offer variations of animations based on specializations or based on very simple randomizations. We have different options that represent the same state, and we just want to have a lot of procedural stuff we can plug and play, and it really is realm dependent. How does this map to CryAnimation? If you keep these five points in mind, and I will revisit them over and over during the presentation, you'll understand where everything in CryAnimation sits. At the lowest level, we need something that takes a skeleton asset, takes animation assets, there's raw computation. This is the core lower level. This is our command buffer. Command buffer is the lowest level. It does all the necessary computations. It doesn't care how we got here. It doesn't care how your game looks like. It doesn't even know if it's a game or a movie or, I don't know, you're trying something with CryEngine. It doesn't care. All it knows is you're giving it a skeleton, you're giving it a list of commands, and it deals with them. The most important thing is that they are stateless. These commands have no idea how long you've been running this animation. They just gave, hey, here's the animation, here's the time we're at, do your thing. And the important thing is it manages the very lower level of animation states. It's very kind of complex what it does, but in theory it is simple. The good news is you will most likely never need to worry about this. Unless you're Alex or Pavel. Sorry guys. The stuff that it does is basically, even if you look at the CPP code, which I'm not going to show you, I promise, it's going to feel intuitive. It's going to clear the idea, clear the field completely, take the skeleton, go back to T-pose, add some stuff, sample some additive animation, scale it maybe, normalize it, mask some joint to just don't animate it. It's doing simple, small, atomic things. Someone else has the responsibility of taking all of this and building a command for every character and passing it to the command buffer. Unless you're Pavel and Hilko, don't worry about this again. This is what it looks like in debug. It's a mess, but once you take a calming breath and think about it, it's not really that bad. It's like clearing the pause, normalizing, syncing with physics, applying some pose modifiers, it's sampling some additive animations, it's adding some big full animations, like here's the full, here's the part. It's doing some nice understandable stuff. So that is the absolute lower level of command buffer, of mannequin animations. So the next step is, okay, let's tackle the other end of the spectrum that's a lot easier. We want to do a lot of plug and play. So we have the concept of pose modifiers. I'm not going to go into detail with pose modifiers because they are completely a topic of their own. The most important part about them is that they are also very simple, small plug and play components. The only contract that a pose modifier dictates is the operate on skeleton. It doesn't even have to do something. It doesn't even need to have a way in order to do it. All it knows is it just gets past the skeleton and it can do whatever. It can write output, it can change, or it can completely ignore it. The targets and weights for every single pose modifier are communicated through the skeleton. This is a much bigger topic, but in my opinion, this is one of the very strongest features about pose modifiers because it means that in the end, absolute control over these can come from the animators. The animators at any point can decide to change the style, disable the look IK based on the weights they do. And we read that and say, okay, you don't want this right now. That means that when you've got a character that has a look IK or an aim IK, and it's getting up from lying down, there is no special need to go in the code and write and say, hey, when sleeping, don't have aim IK. The only thing that's required is that the animator, while doing the sleeping or the jump over, can say the weight for the look IK is 0. And that's it. He's guaranteed to never have it spoil the animation. And that is, again, still maintaining the idea that is throughout all of CryAnimation, having it be stateless. There's no idea what's been happening before, what's going next. I'm just giving a skeleton, and I know what I should do, and I do it. And it's completely atomic. The foot IK, or the look IK, doesn't know if there is a ground alignment running, doesn't know if I'm sleeping, doesn't know if this is a character or a door, doesn't know anything about it. It's just a plug and play component that you add to your character. The history of them is that we used to have, like every other engine, we used to have a lot of predefined IK solvers and some fancy layers on top of them that would take IK and transform it into something like foot IK or pose aligner. These were communicated mainly through the CHR params file, and they were very ugly. They expected some very, very specific parameters. They worked perfectly if you were shipping a biped human being. If you started doing stuff like dogs, or you started doing, not deer though, that's special. If you want to do something like dogs, or if you want to do something like dinosaurs, if you want to do a multi-ped spider, if you want to do a bird, they just didn't work. They were hard-coded to do that. Over the last couple of years, I've made it my effort to take all of these things from the CH params, keep them there because the licensees need them, but sort of replicate them into plug-and-play pose modifiers. This is what you will hear whenever people are talking, and this should be your guideline whenever you think about stuff like, oh, I want to do aim pose, I want to do look IK, foot IK, foot pinning, transitions, wall navigation, all of that, all of these procedural stuff should always be done through a pose modifier rather than hacked into the code. For the future, right now they are completely defined in each CDF file. This is just my opinion, feel free to ignore it. For the future, it might make more sense to move them into their own files, so they're sort of modules to import. That was Sven's original idea, but we never got the time to do that. So that you can import it and then customize it. Basically like every other character builder, you can say, hey, give me an aim IK, or give me a foot IK, and that was it. Okay, so let's go back to the original question, and let's go back to the original question of the presentation. What on earth is Mannequin? So we can do that the other way around. Let's eliminate what we know for a fact it's not. So it's not the command buffer, it's not the procedural stuff, and we are left with these three systems. A system that would take a description of the game state, translate it into animation assets, a way to map said animation states to actual animation assets, and a way to offer animations based on specializations or random differences. And these are Mannequin. The first one is basically called the actions, or what Mannequin considers fragments. And it is managed through a queue. The next one is a mix of something called the controller, the action controller, or the action controller definition file more commonly, and an animation database. And the last one is called a tag, which affects something called options. These are Mannequin. Not one of them, but all of them. Also not the editor. I get very riled up when people mention the editor. So let's look at them one by one. So the first commandment we had, is that not commandment? The first order of business we had, we need a system that would take a description of the game state, or the AI state, or the player state, or whatever state it is, and translate it into something that the animation system could understand. The end goal is still to send something to command buffer to process. So we need this layer. These are communicated through Mannequin actions. Actions are supposed to be just that. They're supposed to be something that logically correlates to a gameplay action. This action can be a one-time shot thing that you do, which is like, oh, jump, reload, crouch, not crouch, jump, reload, punch, melee, press button, just one-time actions. Or they can even be continuous ongoing actions, which I know don't sound like actions at first, but if you think of the perspective of just gameplay, they are. You are now going to do the idle. You're going to do the idle break. You're going to do the move. You're going to do the crouch. These are still actions that will last a while. This is probably going to be looping and running for a while, but it's still an action that is running on your character. The queue, and the reason we did a queue is because it makes life easier to manage the actions. Instead of always having to ask, is the animation finished or not, what you should do is always set up your priorities right, and not bother the animation programmers, and set up your priorities right, and then install actions into the queue, and just let the priority queue handle them properly. What that means is that if I'm now doing a vault on top of something where I have to put my hands down and just really step over something, and the player hits R for reload, or the AI wants to do reload, then I don't have to worry what is exactly happening. What is exactly happening? All I need to do is I'm going to queue reload. Now the priority queue is going to say, okay, ledge is more important than reload. Okay, fine, I'll wait until you're done, then I'll install your reload. So you don't have to worry about what the animation is actually doing. However, it's not just a queue. The most important thing about it is that it's a priority-based queue. This is what makes it really flexible, because not only does it understand order, it also understands importance. If I'm reloading, or if I'm, I don't know, smoking, I still want the hit reaction to play instantly. I can't wait until the reload is done and then play the hit reaction. So it is a priority-based queue, which it means handles interrupting actions based on higher priority actions in the queue, even if they were queued later. As the example we give, if I'm doing a very long reload and I get hit by a hit reaction, I want that hit reaction to play regardless of what I'm doing. The actions are, just to fill in the gaps, actions are defined in an actions XML file. The reason they are defined in a file on their own is that when they are defined in an XML file, that looks like this. I promise I'm not going to show you more XML. I lied. But you don't have to worry about anything. The most important thing here is that there is no relation to anything else. For all intents and purposes, this could be just a fake XML file that's sitting on my computer. It's not really mentioning anything about a character or mannequin or physics or anything. They are completely stateless and atomic, which we are going to repeat all throughout the presentation today, is that they are completely stateless and atomic. Actions are just actions. Hey man, here's what you can do on the player. I don't care what player it is. The importance of this is that when you define an actions file that says walk, or shoot, or reload, or melee, or jump, there's no notion of whether or not this is a character, or a door that slams in your face when you walk in, or a guy with a pistol, or the pistol itself, or the spider, or the hovering robot. These are all actions that the gameplay doesn't have to worry about. Gameplay knows that there's a character that's going to be shooting its weapon. So I play, shoot, weapon, action. I don't care. The animators are going to plug it in. The animation coder is going to make sure it's wired up correctly. Gameplay doesn't have to care. The same with AI. It doesn't really care, hey, is this a big rocket launcher or is this a machine gun? They are completely stateless and they are completely atomic. Mannequin editor, not mannequin, it says editor over there. When you open it and you open the preview, these are your actions. That fancy flashing took me a lot of effort to do this. Appreciate it, please. This flashing red box is where you'll see your actions. This is a listing of all your actions. Okay, so the next easy step is, okay, now I know what an action is. I can easily install it. I know what an action is based on shoot, for example. However, I probably want to do, the simplest case is reload. My reload for my rifle is very likely going to look different than my reload for my pistol. So we want variations based on specializations. Or I want to have multiple options. I want to say every time I play reload, don't play the exact same one. Just give me some variation. So the next thing we're going to talk about are tags and options. We need We need to offer a way of variations on animations based on either a specialization, is this heavy weapon, is this slow AI, is this big dinosaur, or to offer just random options based on the exact same stuff, but to give some more flavor. Every single grunt, I want to have them pick a different walk animation, not the exact same one. So actions describe activities. Tags describe the state of the character or said activity. For example, when you say jump, that is just the jump action. The action is going to play, jump. However, the tag is the one that can tell you, is my character health low? When you said a health low tag or a health high tag, or is this an agile guy that's going to run, or is this the slowed down debuff applied on top of me? So these are the states that are applied on the character themselves. They provide a way to offer specialization and to offer filtering. They seem like the same thing, but they're not. Specialization means if I'm saying this is a pistol, or this is the epic pistol where I want to play the nice new animation, reload animation. So I can set the tag. Filtering, however, is a more distinct feature. What if I say that this is a small door? And going through that small door will allow you to set the tag narrow door. So someone like my good friend Sandy probably does a crouch to go through narrow door. For me, I can go ahead and ignore it. It's basically, I don't care. That tag doesn't mean anything for me. I can ignore it. So it can do also filtering based on, do I have a match for that or not? You can be a little bit more stringent with it, and you can require certain tags. But that is beyond the scope of the talk. The most important thing is tags provide a global and action scoped, also called fragment scoped, also called fragment, action scoped tags. So you can say, here's a tired, or here's a low health. That's something that describes the character. You want to set it for global. You want to set every single animation, whether it cares or not, to know about it so that it can pick it up. However, when I'm saying reload, and I want to set the epic rifle reload, that's not a global tag. For example, my jump doesn't care, my walk doesn't care, my melee weapon doesn't care. All I care about is when I do reload, just play this one. So you can have action scope tags, and on only the reload action, you can say, by the way, you have this epic or normal rifle tag. They also provide grouping for mutual exclusivity. What that means is that if my state is standing or crouching, I can place these in the same group. And so I don't have to say, by the way, please now set me to standing and don't set me to crouching and don't set me to prone. We can put all of these in a tag, and so Mannequin understands that if you're standing, you're definitely not crouching, you're definitely not prone. If you're crouching, you're definitely not standing. So it makes it easier to manage states. They also provide prioritization. I don't like this, to be honest, and in my humble opinion, it gets very, very complex if you also start to think about priorities in tags. However, continuing with our example would be that if you have epic weapon, you set a higher priority than weapon. So that when you do reload, I'm more likely to pick up epic weapon if I have epic weapon, even if two competing systems are setting, one of them is setting tag weapon and the other is setting tag epic weapon, then epic weapon is the one that's going to set, purely because it has a higher priority. That just sounds to me like you are hiding the symptom and your code system should not be fighting, but it is there if you want it. Not one or, of course, it's one or more. They are defined in one or more XML files that look exactly like action XML files. I know I've said this 100 times, but I'll keep saying it because it's the guiding principle in CryAnimation. When they are defined that way, they are completely atomic, they are stateless, they have no idea what's going on. They're just a group of tags that you can set on a character and it's like, okay, sure, we don't care. The file looks like that. It actually looks exactly like the actions XML, not just close because they reused it, but never mind. But in the end, you can see that it is a listing of tags. They are in the groups. They have priorities. Don't worry, you don't have to look at XMLs. Back to the Mannequin editor, just so you get the full idea. When you look at the Mannequin editor, remember we said these are the actions. Here is your tag selection. I'm really sorry, it's kind of dark orange, which is an interesting choice of color, but we can always hit Inish about the colors. It's a very, very weird way to display it, but anyway, these are the tags. Here, there's no distinction between fragment and global tags. When you select a fragment, Mannequin will display everything that is available to you. So you don't care whether it's fragment or global tag, and nor should you care that it's even fragment or global. This is what's available to you, and this is what you can work with. For example, if you look at the example of dodge, you'll see that dodge, for example, has variations based on, hey, is it front, left, back, right? A very typical thing where you hit the space bar and dodge. This is where it is defined. It is still the dodge action, except that it is front, back, left, right. So as far as the gameplay is concerned, this follows a very logical pattern. The game is going to say, what am I going to do? I'm going to dodge. Sometimes, some of them like idle, are just going to be like idle, and that's it. I'm good. However, sometimes you also want to do specializations. You want to dodge left or dodge right. So you can set the tag and have these. Most tags have a fallback. When you say idle, you don't specify anything, it's probably going to be an idle default in the other place. However, they also allow us to do filtering, like I said. So you can do something like dodge and only have these. So in any case, if something wrong happens and someone says dodge up, this grunt, for example, would say, no, I don't have it, and just stand there and be hit. So for an agile character, maybe it'll jump up and avoid the avoid the attack, but the... Hello. Very sneaky, didn't see you. The dodge, for example, for the grunt, you can say, you know what, for the up or the down, I don't care, just don't wire it up. And so it'll be filtered out. The main strength for this is that, again, the gameplay or the AI has no notion of this. I'm just going to play it. I don't know if Mannequin picks it up or not. Okay, so that leaves us with two other components. All of this is nice and cool in theory, but we keep on saying stateless and atomic, and now nothing is connected to anything. And that becomes a problem, because in the end we need a character. So the only thing that signifies that we have a character and the things live together and tie together is the action definitions controller, or the actions controller. The job of the controller is to collate all of the actions that you tell it, and all of the tags that you tell it, to sort of provide you a landscape of every single action that you can commit, and every single specialization on it. It doesn't mean all of them should be there. It's not an exhaustive list. Excuse me. It's not an exhaustive list. It's just giving you, hey, for that character, you can do all of these actions listed in these files, and all of these tags listed in these files. The more powerful part for the action controller is it then starts to define contexts. The idea behind context is it sort of removes the pain of having to manage what can be played when from the animator or the gameplay programmer or the AI programmer. It sort of is the character owner's job at design to figure out what goes where. For example, if I'm walking and I want to do reload, these are really not exclusive ones. It's not a matter of priority. I can walk and reload. So that is a sort of a full body animation. That's an upper body animation. If I'm doing a jump and a walk, these are mutually exclusive. We can't install both at the same time. That doesn't make sense. So we start to get the idea of contexts. Where does this animation live? Is it that place or is it somewhere else? So are there other actions that exist in the same context? Do we need to worry about them or not? They also define scopes. Scopes, coupled with scope contexts, the easiest way to explain it, to be honest, is a working example. A very typical example is you have a player that has a first person and has a third person character. Usually on reload, you want to do a super fancy first person animation. Third person, probably not that important. You want to differentiate the way they walk. Usually don't care about spine limits on the first person. You care about it on the third person. So you want to have scopes. You want to say, not just that, but these things that I'm saying are context can be played on the first person or the third person or both based on these scopes. It also gives a mapping of actions to scopes. It says what action goes where, so that when you say reload, it knows, okay, that reload actually needs to go this way when in terms of first person, and it needs to go that way when in terms of third person, so that you can pick up the variations. And it defines animation layers available. Sadly, a lot of things in the animation system are called layers, so there's a lot of layers we're going to talk about later, but this is not it. This layer is basically how many animations can I layer on top for a single action. More commonly it is one, but sometimes you have complex actions that you want to add a couple of animations in the layer itself. The only point to remember is this is not the animation layers for the entire character. This is not saying me walking plus an additive reload. No, this is if in the additive reload you want to have multiple layers. It is nice for frog clips, it's nice for procedural stuff, and it's nice for just more complex actions, for example. A working example, of course, is, again, imagine if we go back to our example of the regular weapon versus epic weapon. You might say we have two layers. On regular weapon, just play the reload. On epic weapon, I play reload while I'm flipping the guy with the other hand. So you can have an extra layer on top. You don't want just the first animation, you just want to add something on top of it so that you get the full animation. I'm sure you're almost sick of this right now, but I'm going to say it again, because I'm evil. But this is, again, the most important part. This is still saying, okay, you get the actions, you get the tags, you've managed to put them together. I understand it's getting a little less atomic because, of course, if these definitions don't match what's in the actions or tags, it's not very interchangeable. However, all of this still has no idea. I've not mentioned anything about, am I a guy or a spider or a dog or a robot or a car? This has no idea of this. This is still something you can plug and play. For all intents and purposes, if you do your setup correctly, you can end up with an action controller that is the same for the grunt, for the witch, for the spider, because they are still kind of all melee characters, okay, not the witch, but all melee characters that are doing the same thing and they have the same actions. Just because I want to piss you off, here's the XML file. It has the tags, it has fragments, it has scopes, it has scope contexts, which you see. So here's the 3P and the 1P, not here, but anyway. Here's the definitions, here's the full body, here's the weapon, here's audio, and here's the mapping of actions to the scopes. I'm going to go really quickly away from it because I don't want you to focus on the XML side or the technical side. If we open up again the Mannequin editor, you'll see it represented in this section. The action controller is the one that can take all of the info and build you this section. It knows what scopes and scope context you have. It knows how many layers can be in every one. So this is where the action controller, this is not the action controller itself, of course, but this is where the action controller manifests in the UI. Okay, so now we almost have all of our setup for all of our characters done. we still have not mentioned a single asset from the animators. So something is still odd because, I mean, we need to play animations here. So what we need is an animation database. Now, taking everything we've talked about, the animation database takes a specific action defined in the action definition file with a specific tag of a specialization or filtering or priority that has a specific scope. I'm going to run on upper body in a specific context. I'm not just going to run on upper body, so I'm not just going to reload. I'm going to reload with an epic weapon. I'm going to reload an epic weapon on the upper body only, and I'm going to do it only in the third person. It takes all of that and maps it to an animation asset. So the animation database is where we actually finally go and say, okay, when you have all of these, take this awesome epic reload .icaf animation and play it. So, piecing it all together, we have the command buffer, just super low level stuff. We have the pose modifier, as Niels calls it, something spine IK, and it does some procedural stuff. And then we've got an action that gives us everything we can do, everything this character can do, and the priorities. We have the tags and the options, all the variations, the specializations, the distinctions about this character and its fragments. We have the controller and the animation database that map these actions to scopes and then map these specialized actions to animation assets. And you've got Mannequin. Super simple. So, yeah, I mean, I understand that this does not look much more trivial than before. I would actually argue that this is very likely very complex, and as we've seen over and over again with the smaller indie teams, very intimidating. However, it was built that way for a specific reason. Everything we've said over and over, I've said, you haven't said that much. I've said over and over in the presentation is that they are stateless, they are atomic, they are independent. I could take, let's take this example. So I'm going to do the reload epic weapon on upper body with 3P for that animation. But what if someone gives me an animation that looks completely different for our spider character? Spiders somehow can wield now pistols. And so I can do a mapping of a specific action on the spider with the epic weapon tag on the upper body only, whatever that is in the spider, in a specific context on third person to a different animation asset, and the only thing that would change in this entire queue that builds our character is this part. The action definitions are the same, the priorities are probably still the same, the tags and the specializations available are the same, I don't have to use all of them, the controller is definitely the same, command buffer doesn't care, the pose modifiers are probably going to be the same, the only thing that changes is the animation database, and that was the guiding philosophy behind CryAnimation. It was built so that, if you remember when Prophet freaked out the last time, we wanted to have atomicity and portability, no matter how complex it is. As long as they're small, independent parts, you can focus on them one at a time. Look, IK might sound super simple. Simple? Complex? I don't know. No matter what you think of Look IK, it's okay to think of it on its own. If you think of Look IK while jumping and running and shooting and reloading, and what if we are a slow character and what if we have a heavy weapon, then it's just unmanageable. So the idea was atomicity. You have every part worry about its own. You want to think whether a hit reaction or reload is more important? No one needs to care about that. The only one is the priority queue that's defined in the actions, and that's it, and it's forever set. Portability is the second one. As we said, with all this big, long queue, in the end, most people don't do this because it makes it more difficult to manage. But in theory, it is possible to have the same action controller, the same tags, the same options, the same priority queues, definitely the same pose modifiers, definitely the same scope context. Everything is the same except the animation database. Just one file that says, in this case, play this animation. Or even in this case, don't play anything. Back again to the example of a tall character going through a narrow door, crouch. A small character, can't think of any examples, going through a narrow door, I can just walk in there. I can feel free to ignore it. Nothing from the game side needs to change. And secondly, I think the most unique part about Sven, whose praises I sing too much, is that he used to be an AI programmer, then he became a gameplay programmer, then he became an animation programmer. So he sort of had a very good holistic concept of what it takes to manage a character. The player character, the AI character, other characters in the scene, or track view characters, cinematic characters. He wanted to build a virtual character management system. The easiest way to apply it and try it first was animations. It's very visual, it's very simple, it even makes life simpler. But as we've been discussing a little bit on Hunt, there is really nothing that stops you from taking this concept and expanding a bit. What if these tags are not just affecting animations? They should be. But what if they are also something that the AI can read and say, hey, by the way, I'm now a heavy character, I probably should walk slower and turn slower. But in the end, we just made sure that we did what we had this big red block at the start. We want to make sure we can apply all of this to multiple characters without having to do any of the work except for the assets. If you get one of our, a very common example that I was talking to Eric from Epic, that's a nice rhyme. He's the lead animation engineer there. We were talking about what does it take? Like, if you remember the whole big controversy when Ubisoft said it's not going to release female characters for Assassin's Creed, and people freaked out. And I mean, Ubisoft used to say 24 is more cinematic, so I don't know what they were saying there. But it is a lot of work to create a different character. How much effort does it take from our side to create a new character that does everything the same, but is female, so has a different skeleton, and has different walks? It's only the animation database. That is the real strength of CryAnimation. It seems overly complex, but it's not. It's actually one of the simplest ways to manage a character. As I said, the future is probably to take this concept and sort of apply it to different ideas as well. There's nothing stopping you from taking this concept and applying it to AI, or applying it to audio, for example, which is very well tied to animations right now. A lot of our footsteps, a lot of our even grunts, when the grunts are growling and howling, we tie that to the, not just the facial animation that is running, but also we tie it to audio triggers that are playing. The Foley and the footstep detection, all of that stuff can very easily be tied, and audio is a perfect example for this. So you can take Mannequin and sort of make sure that it is not just animations, but has centralized place where everyone can sort of, if you play any of the role-playing games, it's your character sheet. Everyone can say, these are the actions you can do, here are the factors that affect you, the buffs and the debuffs, and everyone can install their little parts. And then everyone else has to worry about it. Like, you install all your parts, and AI, okay, now I need to walk a little bit slower, and animation say, okay, now I want to play the epic gun reload, and like audio says, okay, I'm going to play a female voice, and you get these variations from them. Okay, as always, I was a little bit too fast with my presentation. So if you've been listening, I don't know why, but thank you.